Good morning, one and all. My name is P. Mahendra. I am here to explain graphical processing units of and quantum chemistry of physics subject, and I am from CSMB AML department, and my guided faculty is Mrs. Sujani Singavarpu ma'am. Let's see our topic. First of all, we see introduction. Introduction about quantum chemistry involves solving complex mathematical models of molecules. Traditional CPU-based methods are computationally expensive. GPUs offer massive parallelism, parallelism that's a, that accelerates quantum chemistry stimulations. Means quantum chemistry involves solving complex mathematical models of molecules. Traditional CPU-based methods are computationally expensive. GPUs offer massive parallelism that accelerates quantum chemistry simulations. Next, we are going to see what are GPUs. GPUs are nothing but originally designed for rendering graphics. Means they are designed for only rendering. They are originally designed for rendering graphics, and it contains thousands of small cores optimized for parallel tasks. Means that means it contains means it have thousands of small cores optimized for parallel tasks. Next, third point is ideal for scientific computing. Means it gives an a scientific idea for computing, especially quantum chemistry, especially for an quantum chemistry. Next, we are going to see why GPUs in quantum chemistry. Quantum chemical computations involve repeated matrix and tensor operations. Means the chemical computations involves repeatedly matrix and tensor operations. These operations can be parallelized efficiently. The operations of the GPU in quantum chemistry can be parallelized efficiently. And next third point is GPU acceleration reduces simulations time for days to hours. Means GPU's acceleration it reduces and it downfalls to simulation for time for days to hours. Next, we are going to see key quantum chemistry methods accelerated by GPUs. Means how the key quantum methods are accelerated by GPUs. Hartree-Fock density functional theory, coupled cluster, molecular dynamics, configuration interaction. Configuration interaction. The key quantum chemistry methods accelerated by GPUs and Hartree-Fock density functional theory and coupled cluster and molecular dynamics configuration interaction. Shortcut for that is CI, and molecular dynamics shortcut is MD. You can call it as MD. Coupled cluster, its shortcut is CC. Next, we are going to see GPU architecture overview. Here we can see the GPU architecture overview diagram. Here is the diagram. You can observe that compute cores are moving from memory access from compute cores and channel, and next to the and context and memory access and device memory, and From device memory, it comes again to content page table. Next, undefined unified virtual address space, host memory, DMA DMA interchanges memory access through the MMIO, register access through MMIO. Last one we can see that CPU. CPU has apps, libraries and driver. GPU source is a management model. From above picture you can see performance gains. Example DFT calculations on medium sized molecules. CPU 10 hours, GPU 45 minutes. GPUs improve scalability throughout the throughput and energy efficiency. Here is an example. You can see that DFT calculations on medium size means mediumly sized molecules, and here is a GPU for 10. It runs GPU for 10 hours and CPU for 10 hours and GPU for 45 minutes, and GPU improves scalability throughout and energy efficiency. Next we are going to see challenges in GPU quantum chemistry. Porting legacy codes to GPU is complex. Memory bandwidth limitations. Precision issues double versus single. Need for specialized programs CUDA and open. Next we are going to see the future directions. The future directions are integration with an AI and a machine learning, quantum computing plus GPU hybrid architectures, means the rapidly integration with the AI and machine learning, and quantum computing plus GPU hybrid architectures could based GPU clusters for collaborative research, development for universal GPU frameworks. And it has main means it has a development of universal GPU frameworks. Next we are going to see impact on research and industry. How it impact on research and industry, we can see that drug discovery, accelerated molecular screening and lead optimization through rapid quantum calculations. And it means it accelerated molecular screening and it leads to optimization through the rapid quantum calculations. And the materials designed for that is high throughput discovery of a new materials with a tailored properties for semiconductors and batteries. Means high throughput discovery of a new materials, discovering a new materials and with a tailored properties, mean the measurement of the uh, exact properties and for semiconductors and batteries. Next we are going to see neural integration, seamless integration with the machine learning pipelines for a predictive modeling and neural network surrogates, means seamless integration with the machine learning with a very easily integration with the machine learning pipelines for an predictive modeling and a neural network surrogates. And next point we can see that cost reduction. GPU accelerated DFT reduces computational costs by approximately 90%, and means the costs are approximately reduces by 90%, demonstrating against the access to quantum chemistry. Next we have that hybrid quantum classical computing, the future for dinner. NVIDIA DGX quantum, hybrid quantum classical computing, the future for dinner. NVIDIA DGX quantum, integrates GPUs with a quantum processor for an ultra low latency quantum control. Means it integrates with an quantum processor for ultra low latency quantum control, enabling seamless communication with the between between the classical and quantum domains. Next generation. Next generation, we can see that combines with an classical GPU acceleration with the quantum error correction and adaptive algorithms, promising to the scale quantum chemistry simulations beyond the classical limits. Means it combines with the classical GPU's acceleration with the quantum error. Quantum means small error within correction and adaptive algorithms, promising to the scale quantum chemistry simulations beyond the current classical limitations. Now, finally, we are coming to conclusion. In the conclusion, we can see that GPUs have revolutionized computational quantum chemistry. Next point, we can see that means the GPUs are completely revolutionized and computational quantum chemistry, offer massive speedups and cost efficiency. Continued research will expand GPU usage in next generation chemical stimulations. Means this continued research will then expand GPU usage in a next generation chemical stimulations. Thank you for listening my presentation.